That's
Any
before
way you want. Just remember what your number is. 41. Where's your lid? Right here.
Yeah, make sure it's lid on. Oh yeah, yours gonna be different.
Yeah, you're not like
everything. Selena.
You're tighten it? Yeah. Where do you want? Anywhere you want. You're 42.
So write that down, okay? Numbers.
43. 44. 45.
All right.
Okay?
There we go. Alright, so there's the mounting done here with the mass spec. And then what we're going to do is we're going to head back to the actual computer room where that's where we're going to be actually running it. Oh, go ahead.
Okay, the first thing I want to show you guys is what standard looks like for today. So you guys have already done HPLC, correct? Yes. So you all know what an HPLC graph looks like. Yes. Caffeine elutes out at 4 point something. 4.7. This one is at 4.6, but generally it's 4 point something. 4 point something. Beautiful HPLC graph. This is a very typical MS graph. Looks like horridness. You would think that or that would be caffeine. But you have to go based off of what your HPLC graph told you. So your HPLC graph told you that it eluted out at 4.6. Now you need to give 0.1 to 0.5 seconds for the MS to pick up what the HPLC was saying. So instead of going over here to 3, you need to go past 4.6 in order to read your caffeine. So whatever your elution time is, you need to go past that to find where your peak of the actual sample is.
I have a question.
Yes.
So you're saying that so once you look at the elute time from the HPLC, you have to, it's a different eluting time in the MS.
Slightly different because it's going to.
Just a little.
So.
Yeah, but that shouldn't.
Okay, so what's going on is you have a sample, it ejects in, it goes through a column which gathers everything up based on its polarity, and then it reads it through the UV detector. Then it sends that massive sample to the MS. It has to go through a whole bunch of coils, a whole bunch of tiny little capillary tubes, be evaporated before it can finally hit the detection.
So you're saying that the time that it takes for it to go through all that, you add that time basically to the MS, you add time.
Right.
But doesn't that start from the beginning? Exactly. When it actually, that whole time that it's going through that, it's not taking into consideration. It's actually, once it enters the mass spec, that's a new, so it should have the same.
Well, it's only off by like 0.1.
Yeah, so it's not that long of a difference.
It's not like it's a minute off.
Yeah.
It's only off by like 10 seconds.
So it's contact closure, Caesar. That's the reason why, because they're not the same instrument, they're not the same company. Two different separate pieces of equipment. That's why.
If you look at this, based on here, this is right here, 4.6. See how it's just starting to take off? So it's about a second behind before you see your actual caffeine. 0.1. So it's not instantaneous. It's not like 4 and 4. It's 4 and 4.1. It's just how the machines have always.
Yeah, it has been set up. That's why it's contact closure, Caesar. That's the reason why. It's two separate. The instruments for one company, the mass spec was bought from a different company than the HPLC. So there's a 10-second gap in between the two to contact. Yeah, that's why. Yeah, if they were on the same thing, then it would be instantaneous like the way you're saying. That's what happens.
Another thing, when you open up these graphs, because you go over here to open or whatever, it opens it so that you can't do anything about it. You can't move it around. You have to click this little pin right here in order to search.
Push pin. It's like to kind of put it on there.
Search for your sample. Okay? Okay. So now we're going to actually do the setup for what you guys are going to be doing today. So the first thing you do is you're going to go over to Excalibur, which is this program right here, which is this X. It's down here at the bottom. Okay? And I've already loaded the sequence setup for you, but you're going to click sequence setup, and it's going to be loaded here. The only things you're going to change is instead of Mountain Dew Dr. Pepper test, you're going to put your name. So you're going to double click into the bar, or I'm sorry, single click into here and change the name. Okay, you're not going to do anything to the other one. Then when you're ready to run, you're going to highlight it so that it's blue, and then hit this little test tube with an arrow running through it to hit the run sample. It's going to pop up a box, and you're going to say OK. Then this is going to start going through contact closure and trying to get ready. While that's waiting, you're going to highlight the second row, hit the test tube again, hit OK again, hit the test tube twice, hit OK twice. So you're going to do the clean 2 times. So you're going to highlight, hit, OK. It's going to look. Highlight, hit, OK. Then you'll have 3 things running, waiting to run. Does that make sense?
So that's what we call the queue. This is waiting.
So I'm actually going to walk you through it, and they're going to watch you do all the name changing and stuff. Then you go over to the HPLC, and this one's already running, and it's already going. The only thing you're going to do different than I think you guys did last semester is you're going to go into easy sequence, load the caffeine D sequence, and I'm going to change it for you right here so that it says 3, and it's going to load them here. From here, you're going to change the name of everything. So this is going to be clean because you don't care about it, and this one's also going to be clean. So you're going to put your name in here. You're going to put what your vial number was here, so it picks up your vial.
That's very important. The number.
If you don't do that, then it's going to pick up
Number
methanol,
one.
and you're not going to get
Yeah,
it.
which is number 1.
One sample, right?
So it's just
Can we get twice, just like a longer period of time?
Right. So the clean runs right now are at 15 minutes. And so it's going to clean 15 minutes, then start over clean another 15 minutes. Okay? Then once you change the name here, you're going to say hit save and add queue, and it's going to start. You have to do Excalibur first. Excalibur is the one that waits for contact closure, which is just a little signal that the HPLC sends the MS that says, hey, I'm sending you a sample, wake up. If you do it the other way around, the Excalibur won't start acquiring data until the second run of the HPLC, which will be your clean, which will do you no good. Questions? Okay, so now I'm going to walk you through, so you can set it up.
Can you set all the queues up at once? Or no?
That's what we're about to do.
Yep.
Just once, and then type. No.
Which way you have the option? Click on the side. No, you already clicked on it.
Okay, now you can run it. Okay. Now do the clean. So click on it.
Yeah, the clean.
Click on the where says okay. Now do the same thing for the clean. Do it twice. Nope.
Next thing, right?
Good. Now go to your HPLC.
And you see how you did those 3 things? The 3 things showed up on the left-hand side, those drop downs?
Easy sequence. Slow your or load it for you, change the name. How do you do it? Yeah. What's your file? Now save that. The cool thing is you just have to watch it. So you go to instrument control right here. It's going to show you that it's going to start. And now you started. Now the next person can come in. So who was 42? Or who was next? It actually doesn't have to go in order.
Doesn't matter.
You want to go next?
Don't have to wait.
Well, Selena, you have one of those caps, right?
Yeah.
You have caps.
Okay,
So
caps
Selena
are gonna
and
go last.
yeah, and Rebecca. Okay. So we'll have only because theirs may evaporate off. That's why we're using those caps to see if it works fine when you need to penetrate through and pop it out.
All right, then go to Excalibur. Change the name. Nope, you have to highlight the thing. Now. And one more time.
You see how it adds it every time? So every time there'll be a total of 3. And there's 5 of you guys, so in total it should be 15.
Okay, now go to the HPLC. Now go to using sequence. Hit load sequence. Open caffeine D. Open. Change your name. Now hit what your file number is. And save that. Done. All right. And you're done.
All right. All right, Caesar, you're up.
What's the thing? Why is this delete? Is it supposed to be delete?
I'm deleting them with you.
Oh, okay. We'll do that.
So the sequences is what already Cassandra had made for you guys. That has all the parameters, everything ready to go. The method.
The sequence is what
And
they're
it's
making.
clean beforehand, so then my sample runs and then clean after clean.
Right. Yep, save that. You're done.
I thought I was slow.
Either one of you.
Sure that I do.
All right. And so the idea by doing it, like I said, there's lots of different ways of doing this, but the idea is like to have you guys just load up all your samples as a class and just come back when it's ready. Or if you want, so you can actually come in, load up the method, do the sequencing yourself, then scan your samples, and then just collect the data, and then log off. Done. And then the next person who, whenever they want to come on, will do exactly the same thing. They will load up their method, a sequence, which we'll tell them where we'll be at. They do the sequencing, and then they will just take their sample. Here, we're just doing it all in one swoop. So when you guys are ready to come back in, whatever time it is, like for Rebecca, you come back tomorrow or on Tuesday, whatever, to pick up the data. You're done.
Okay.
No, you don't have to wait.
So we have to wait.
No, you're done. You don't have to. Yeah, technically you could. That's the idea. And then you can log on. If you're on this computer, you log on, and then you, boom, there's your data.
So in
That's
order
cool.
to get your graphs, do you
then
usually email
set up
it to
text on the
us
side.
and save it to the computer and email it, or?
So to get your HPLC graphs, you can save them to either the desktop or your flash drive as a PDF. And I can show you how to do that if you're long enough. For the Excalibur, the only one I know of how to do MS is print screen.
Snapshot of it.
Excalibur is specifically for that.
Yeah. Yeah. And whereas ChemStation is for HPLC. Yes, you can. Yeah. So it's a pic. Yeah. No, like I said, don't even worry with it. Like that's the point. That's the advantage here is like you'll be here for you, ready. So you want to come back on Friday tomorrow, you can, because we'll be here.
I want to start working on it on Tuesdays.
Okay, all right. So that'd be cool. Yeah, but that's the advantage there. It'll be there for you, and the best way actually is to have done this thing put it on the cloud. So basically, you guys can just log in from home to here, and then you boom, just get it without having to worry about USB or anything like that. That's another part we're trying to cut out. However, and this is something that we run into a problem is because there's a firewall issue. So you have to get permission first of all from here to get you in, to get approval, to let you in through the firewall, and then finally get able to remote access the computer here. So that's the only thing. We're working on that. That's the only part. So right now, this is the best we could do here because why? We're still at Dominguez Hills.
So
But
with
we,
the cloud technology, I'm sorry,
Yeah.
with the cloud technology, does the system has to be running for you to access from home?
the server will always be up and running. It's never going to shut down.
Okay.
So the idea is your data you collected will be available 24-hour days, 7 out of the week. As long as the server doesn't shut down, it's on that cloud. The machine, though, it's the same idea, is to have it on all the time. It never shuts off. So the idea is you could take data, even let's say at midnight or 1 a.m. in the morning, and just run it. You're done, and then there's your data. You're ready to go. That's the advantage of having done this thing as well. Okay? So, but we're not there yet with that.
Let's just save the file. So let's just say that this was your file. Let's just say it was. It's not, but let's say it was. The way that you would save it is you'd go here to print, and then have it print into Adobe PDF. And you can print it to the desktop or whatever, and then this computer that you're logging into has internet, so you can then sign in and email it to yourself. That's for HPLC. Now, go ahead.
No, I was just gonna say, so by when would the data be available for sure?
Well, what number are you?
You were number 3, Caesar. You were the third one.
So 45 times 3?
So what's that? 135 minutes, which is 2 hours and 15
Something,
minutes.
yeah. And then you can come in and take your data.
Pick it up. And like I said, guys, you don't have to do it today. It's going to be done. It'll be here. So like Rebecca, you'll be the last one technically, but you don't have to wait here until like almost like what, 5 or 6 p.m. to get it. It'll be done. You come in tomorrow and pick it up.
Okay.
Done.
It'll still be here by Thursday, right? We're going to be here Thursday doing the anyway. It's going to be here until I leave the school. Okay. Which will be this time next year. So, worst case scenario.
The software and everything, nothing is deleted or anything like that. So
Yeah, it's saved.
Yeah, and on this thing, going to the server, basically, since that thing has a huge amount of space, nothing gets deleted, and it gets backed up. It is meant right now in case if something was to happen where, say, there was a power outage or the hard drive just crashed, something like that. It's been backed up. Edgar set that up first, so that way it's supposed to repeat. It's supposed to back itself up almost every day. So 24 hours, it backs up. Next day, it backs it up. So you're never ever gonna lose this stuff. The data will always be there.
So in order to get the data from the HPLC, you have to go under the data analysis tab. That's how I went to find the print or whatever. And then in here, you need to find yours, which it's, how do I explain? In the column, it's not named after your name. It's named after the method that you used. So you need to find the one that find the method that you used.
Caffeine.
So I'll show you. So over here, this is what it's going to look like when you go to the data analysis tab. You need to open this up and then go down to caffeine D to today, which right now it's running still, so it's not going to show. But you're going to go to the one that says 422, and when you open it, then you can see, oh, that's my name, and that one's yours, and that's the one you print. This is the standard.
Oh, okay.
Okay?
And that's all we print that.
For HPLC. For Excalibur, you're going to go to this first tab that kind of looks like a Venn diagram that you had to do in elementary school. So a whole bunch of boxes and arrows. When you click on it, you get this, you're going to go to the Qual browser and open up yours. And it's going to be based on your name in this one.
This is for the mass spec.
This is
For the Mass Spec now, that's right.
So for Mass Spec, ours is, I don't know why that one got me. That's weird. I wanted to save this. You could.
So you click on your name and then that's
Yeah, and then it pops up. Yeah, I don't know. The printing on this one doesn't print to PDF, so the best thing you can do is take a print screen of it, a snapshot of it, and then edit it in Paint, which also is on this computer, and then save it as an image, like a JPEG image. That's the only way I know how to save these graphs, offside of this computer.
Oh, you can.
You can. It's just slow. You guys can try it this way and tell me if it works.
Yeah.
I've never done it, so.
You can save that one right now. We just put it on the desktop, on that computer. Yeah, you can just save it on there. Then you go on the desktop, it should be on there.
Dr. Rodriguez, do you guys have ChemDraw?
ChemDraw, no, but I know you're talking. No, we haven't like had a need. Well, let me stop. Let's see, just to end it then. All right. So that's it. So right now, all we're doing is just waiting, right? That's it.
Yep.
We just wait.
So that's your first graph.
That's your first graph, right?
I'll take your graph.
Looks really high.
And that's common. That's the expected look. So these two peaks here are something else that the methylene chloride extracted out from the soda itself, which is expected. There's a lot of sugars and crap in soda. But this 4.7 is your caffeine. So now broad because it's above 20 parts per million in the machine.
Yeah, that's
and the
broad.
higher concentration you have, the broader
the peak. That's the reason why we found that out the hard way. So we knew that.
The first time we did it, it was like this.
It was pretty bad. Yeah, that's the reason why we thought it was broken. It wasn't. We had completely contaminated it.
So now the Mountain Dew was fairly good.
So that's it. So and then said the best thing also is we're not in that room, so it was all done, kind of like cyber enable a little bit. At least we're not in the same room, in a small little room. We're just running it from here for right now, and you guys are getting the same experience if you guys were actually in that room in front of the machine, but there's no need for that.
That's the standard. Oh, it's still in box. Yours isn't done because the prison is still going?
Can you see it live, Cassandra? The thing,
Not
on the
from
mass spec.
HPLC. But the clean is, she wants to copy that.
Okay, no, that's cool.
So,
But is there a way to see the mass spec running live from here though? Right? Okay. So when I was doing it clean, oh man.
that's